If you were an engineer and you had to go reduce your Datadog bill or your AI bill, what would you do? And one thing we realized early is like, well, you wouldn't like just go into the code and start coding, right? The first thing that you would do is probably look at the bill, look at your metrics, try and figure out where the problems were, and then go into the code and make the changes. So we basically said, well, could we build a system like that that does a bunch of the AI coding stuff, but also gets that context of your bill and your observability data to go find the problems and fix them. So our goal is to basically make a product that helps our customers reduce all of their cloud spending.
First of its kind, if I've seen anything like that before.
Yeah, it's a bit different. Like everybody's got the tools that like try to get the right number of reserved instances or cost savings plans, and that's great. But these days, more and more stuff that we're using as we build applications are usage-based billing models, where you're paying by the token or the gigabyte or the API call. And for that stuff, it's your code that is kind of directly spending. So to fix the problem, you kind of got to need to find the place in the code that maybe is doing something wrong, and once you found it, put in the fix. A lot of times it's just like add a cache or buffer responses or follow a best practice that the service provider has already kind of documented, but you got to find the problem first, and that's where we come in.
You must have tried like different types of frameworks before, like maybe LangGraph or something similar. So why didn't those frameworks work for you guys?
Well, we looked at them a bit, and we'll talk a little bit more about LangGraph. Like what we needed to do was, I should say, like our first prototype of this was an agent-based system where an LLM was controlling the whole flow. But we had a lot of data to deal with. We had to deal with all this billing data, all this observability data, the whole source code repository. And so we started like decomposing the problem into really smaller chunks. And we found that a lot of those decomposed chunks actually were deterministic code that we wanted to run. And really the whole workflow was pretty deterministic as well. So our requirements when we sort of thought about it was we want to have a deterministic sort of graph of many, many small tasks, tens or hundreds of small tasks that had strong caching, so that we didn't have to run things over and over again, that we could mix in AI where we needed to, and especially because we were mostly working with code, we wanted to work with coding agents as our sort of abstraction for the AI. And we wanted it to work well with Kubernetes. Sort of, we wanted to run these tasks sometimes in their own pods for isolation reasons and other things. So those are some of our requirements that we were looking for in a framework.
Yeah, I mean, at the beginning we did look at things like AI SDK and LangGraph, and we were trying to make them the part that would run the system. But in the end, like Craig said, though the LangGraph would have been just the smallest part of our system, the part that executes the AI little task that we wanted to do. So it's not that we threw those things out. We just use a coding agent instead. It's got a lot of tooling already built in to do all the code related stuff, so we didn't have to develop that ourselves. And they do just that small little bit at the inside the tasks that need AI specifically.
The other thing that's kind of changed a lot is the calculus for when to use an open source library and kind of adapt it to your needs versus when to kind of help use Cloud Code to code up a custom framework that is what you really want. It's changed a bit. Like it's just so much more possible to quickly generate a whole bunch of code or a framework now that sometimes you have to really think whether it's better to take the sort of proven, debugged, widely used thing that doesn't quite fit your need and adapt it, or just build exactly the thing that you want.
There's been a lot of discussions around like workflows versus agents. When looking at the system that works for you guys, how much of it is a workflow and how much of it is an agent?
I think so. If I understand the difference, it's sort of an agent is you've got AI kind of guiding the whole thing, and it has a lot of flexibility to decide what's the right next step to take and things. Whereas I think of a workflow as a bit more directed, like it's fixed what's going to happen in what sequence. So our thing is much more, and if that's the distinction, like our thing is much more like a workflow. The big steps, the set of dependencies are all defined. There are pieces of the processing analysis where we'll go out into kind of agent mode and like let it run a little while. But to make the system reliable, and we could think of a way to do it in a way where it was a workflow, and so that's what we.
We're basically a workflow. We have, again, at those moments when we need an AI, we will get an AI and it'll be agentic and it will spin off other tasks and it'll do the things it needs to do to accomplish that specific task. But the overall framework is trying to be a workflow to kind of achieve a goal. We ran 277 tasks here, and that's basically that organization of the workflow and how we're able to accomplish the goals we want to accomplish. And in this, we ran a lot of tasks at the beginning that were, we're fetching data from the bill, from the different providers in order to collect all that data. And some of that takes a little bit longer than others. This took 3 minutes to collect some log samples, and then once we're done collecting samples, we then analyze the code. So we need to analyze the source code. We download the source code, analyze the source code. That will need AI. And you can see some of these tasks have like costs on the right here. So this here is like, guess the code applications that are in the product. That took 1 minute and 39 seconds, and that was an AI task and has a certain cost to it. And so this is the way we are able to kind of debug, how long are things waiting in the queue? How long are things running? How long are things, waiting for a bunch of Lambda tasks that they have queued up to execute? So, this is the view we have, and we also have once the task is all the stuff is done, we have a view of how much this scan cost. This is an expensive scan here, but so we have an idea of how many tokens were used, how many different API calls we made, and these API calls are basically each one of the 126 is a full agentic kind of coding agent that's gone off and done a bunch of its own API calls, more than just the 126 here. Each of these are just single points where we invoked a coding agent to accomplish some task for us. So yeah, this is basically how we can kind of go through our scans and develop them and debug what's going wrong and what's going right.
Walk me through how the task orchestrator works.
Yeah, so
with the rest of the system.
Yeah, so this is the view of the what the task orchestrator has done. But what it actually is doing is we call it the task orchestrator because it's orchestrating all of the tasks that we have. Like an orchestra, they all have to play their musical notes at the right time. And so it can determine, based on the knowledge that different tasks need, what order to do tasks and how many tasks can be run in parallel. And so what it does is it'll queue up a bunch of tasks all in parallel if those tasks don't depend on each other, or the knowledge they provide is not, kind of needed between them. And then once we get to a point where some of the other tasks that are waiting for the source code. So the task that's going to download the source code will run. The task orchestrator will hold off on running the task that needs the source code till it's ready. It will organize all of the knowledge so that when a new task runs, let's say it's an AI coding task that needs to know about the AWS bill, the task orchestrator will make sure that specific bit of knowledge is available to that task, not all the knowledge we've collected, so that each individual AI agent is kind of confined to what it needs. And then those tasks will run and it'll keep going until the full scan is complete. It organizes the disks for the tasks, what each pod will have on disk, the code or the bills or logs, whatever the task is looking into, as well as any analysis that other tasks have done beforehand to kind of help kind of guide those tasks to accomplish what they're doing. Yeah. So that's what the task orchestrator does. It basically just plans out the full scan. And it also does things like keeps the relationship between the tasks in memory so that when a new task is running, it can queue up something that it needs that hasn't been foreseen. We can actually get the AI agents to decide if they need more knowledge that's not available, and it'll queue up stuff and put those on hold until the data is available for them. So it does all of that kind of as part of its system. And yep.
You didn't really talk about what tasks are, but
yeah, I mean, so a task is it could be you mentioned earlier, it could be a deterministic bit of something we want to do, or it could be an AI specific thing. But every task is just a little step, we're collecting knowledge, we're analyzing something, and it has a bunch of dependencies for the knowledge it needs, and it has an output. And the output is actually very deterministic. We make sure that everything has a schema and it's cached. And it's now, if you need to run a scan again, it won't need to rerun that task if nothing has changed. And that's another thing that the task orchestrator handles. Things like if the data is old, it'll rerun it. If a dependency of it has changed, it'll rerun that task. So there's a lot of conditions that it handles. It could even be something like the source code we downloaded is now stale because there's been commits that have gone into the code base. It'll be able to determine that and rerun that task as well. Anything you want to add, Craig?
I think it's interesting the way we use MCP servers with tasks.
It's a good segue. Yeah.
Yeah. Were you going to ask about that?
Yeah, it's one of those things that stood out to me when I first saw how you manage like MCP servers and how I'll let you reveal the big secret, but yeah, it's just like one of those setups that I've never seen anywhere else before.
Yeah, so that's another thing that the task orchestrator handles is anytime that knowledge needs to be passed around in the system, it kind of determines the best way to share that knowledge to the AI agents that are going to be using it. So if it's knowledge that's just like a bunch of data that the AI agent's going to need for sure, it will put that into the context of the agent. But if it's things that the agent might request, it'll generate an MCP server specific for that pod in Kubernetes that is running that coding agent, and that server will have only the set of tools needed for that task.
And the tools are also generated at runtime.
At runtime, everything's generated at runtime. So it determines what tools are needed. It generates an MCP server with a limited set of tools for the task, and those tools could be many things. If it needs to produce a graph, for example, instead of asking the agent make us a graph, it might produce an image, or it might produce some text for us that could be converted to a graph, or HTML maybe, but it's not going to be deterministic in the way that we can leverage it to show in the UI every time. So we make MCP tools. If we know we want a graph from this agent, we'll make an MCP tool where it can provide the exact information in the right structure to make the graph. And it's the same thing with the output. If we want a structured output from the coding agent, we'll provide it with a tool that will give it the structure and make sure that it follows that structure when it's going to return its response. Yeah.
It really reminds me of Claude skills. So it invokes a skill when the task requires the knowledge to do the task.
That's a good thing you mentioned skills. We also leverage Claude Code skills. For example, if we're going to use Claude Code as a coding agent, if we're going to put data on disk for it, to let's say the data is too much to fit in a context window, but we want to allow the coding agent to be able to go through some data to find a solution to the problem. We'll give it, instead of an MCP server, which has token limits as well, and we don't want it to go back and forth with the MCP server to analyze data, which it could do with coding. And if it won't fit in its context, we'll actually put a structure on the file system for it and give it skills that teach it how to go through that file structure to get the data it would need. So the coding agent can decide what bits of data to go collect. So yeah, we leverage skills as well. We leverage as much as we can in order to make it as efficient as possible.
Yeah, skills are great because they only consume like 50 tokens per skill defined.
Yeah.
So it's great, much more efficient than like an MCP server.
For sure.
When you're fetching data. How much context is shared between like the task orchestrator, because it has I'm assuming, the context of the full run, and then the task inside of the task orchestrator, or the tasks that are queued by the orchestrator. How much of that context is shared?
So just like everything else, the task orchestrator decides based on the task that's going to run what context it needs, and it will actually just give it the piece of context that it needs. So, for example, if we're going to get it to make a coding fix, let's say we found a problem in part of the code, the task orchestrator might give it the context of just the knowledge it needs for that repository or that project, and it might even only give it a disk with just that repository as opposed to the entire code base. It can also control how much of the context to give based on the individual problems that are trying to be solved. So let's say we find 10 cases where they're logging too much, a tight loop log, for example, right? If there's 10 cases, we can actually, the task orchestrator can give the bits of information for each of those 10 cases to 10 different AI agents, and each one of them only has the context necessary to solve the individual problem, and then they'll return the correct code for the different problems.
And how do you decide, I guess, which tasks to run in isolation or in sequentially, and which ones to run together in parallel?
Yeah, that's, again, task orchestrator just handles that by determining the knowledge they need. So if the knowledge is available, it'll run as many of them in parallel as it can. Yeah, we have limits. Obviously, we want our bill to be reasonable as well. But yeah, it can run as many tasks in parallel as the knowledge that we have currently collected permits. Yeah.
For sure. Yeah. How do you decide like which tasks to use AI, and which tasks to be like a predetermined code and workflow?
Basically, if we can do it with predetermined code, we do. It's cheaper, it's more predictable. And a lot of stuff that we have to do is grab a bill, read it, extract some data from the bill. Like we'll generate some code that does that in a deterministic way from then on. But there's other stuff where we have to look at the customer's source code and generate a code fix, or that would be really difficult to do any other way than AI. So we couldn't have built this system 5 years ago without these bits of AI sprinkled through, but we don't lean on it any more than we have to for cost and reliability and predictability reasons. But one place that we've been recently using AI a little more in the system than we expected was with like customization hooks, like any
custom problems and all that.
Yeah, like we're building this enterprise product that people will need to adapt to their organization. And in the old days, we would build like APIs and some kind of customization facility, like configuration and other things, maybe plug-in system, that kind of thing. And what we're finding is that by allowing people to add in custom prompts in certain places in that big hierarchy of tasks, they're able to kind of adapt the system enough for their organization without really writing any code, just adding prompts, which is like, that's going to be super cool if we can get that working all the time.
Yeah, it's pretty accessible to people outside of developers too, I'm assuming, because it's just prompts, right?
Yeah, for sure. One example actually that you were able to do is, let's say the system analyzes your source code, and we're using AIs to detect what components you have. We might miss a component, right?
Mm-hmm.
But if the user sees that a component is missing, they can simply edit a prompt, give it a little bit more information, and it'll run the scan again and detect all the parts that it missed. So that's
and
like
like
a
the
simple
steps before that step,
exactly
cached, right?
Yeah, everything before that is cached, and it only needs to redo the stuff that depended on that knowledge. So it's a very flexible system that way.
Yeah. So since like a lot of it is workflow based, and that leveraged your subject matter expertise for many years doing this kind of work, is it possible to cover all possibilities and all paths to solving these problems just by building more workflows?
Well, I think we'll get to a day where we could load the agent with the right context and let it go, and it would find things that we didn't think of. I think there'll be like we'll reach that point. In a way, I think we chickened out a little bit from just like that. To me, seems like a little bit of a high risk path at this point in time. So we scaled back and we said, okay, we're going to use a lot of deterministic code to deal with this, but wouldn't it be great if, we could just load into a coding agent the right cost context and the right observability data, and these things are already trained on lots of stuff on the internet that talks about like the best practices for using Datadog or OpenAI, and so like you could picture that that's like a recipe where it's got all the data and it has all the context and could go do it. So I hope we'll get there. In the meantime, we're gonna build it this way.
Yeah, but I think that if we wanted to, we could. It would be more work for us now because we can't just ask an agent to do it. But we could make it cover anything that a customer wanted it to cover. Like our system is flexible enough. What we have now, it's not all AI and automatic, but we could customize it to do basically anything, I think. Right? The system is such a way that if somebody wanted to find, I don't know, not cost related stuff even, it could find it for them and we could develop a bunch of tasks that would do basically anything in somebody's code base.
Yeah, it's sort of like like a metadata system for code bases, or a sort of it builds another layer of context around your code base. That right now that context is cost data, and we use it to do cost optimization, but could be other things too.
Yeah, I actually joked with you before about coffee machine, exactly. Like if you wanted to develop a coffee machine with our system, we can make it happen. Just some tasks to determine the right types of beans and the quantities to use, and some AI to maybe let you customize your flavors the way you like, and you got a coffee machine system.
Yeah, it's just that it's gonna run on an Opus 4.5. It's gonna cost $125.
It's gonna be very expensive coffee every time.
Yeah. So go back to the MCP conversation in context. So right now, some companies are coming out and saying, like Anthropic, saying that it's better to let the agent write code to hit MCP servers, to have better context management, but also like more efficient token usage. So do you guys plan on letting or generating MCP servers that are around that kind of pattern, or do you still want to stick to like tool calling and have a bunch of tools to call?
I want to take this?
Yeah. I have a couple thoughts, but you go for it. You're gonna know better.
I don't know. So we have been thinking about this already. So that's kind of why we only use tools when it's kind of the best way to give the AI the access. Like if we can give them access in their context directly, we can avoid any tool calls. Some of the coding agents, like Claude Code's latest releases, they actually have some built-in mechanisms for handling MCP servers in a more programmatic way. So we might not have to do as much as we thought we did, but we're already leveraging skills, and we're leveraging a file system based delivery of data so that code can be used. Claude Code the skill gives Claude Code access to information on how to use like just bash commands, JQ, ways to access the data that we put on the file system for it. So it can make a complicated kind of script file to go and analyze the data without having to use the MCP server. So we try to use MCP only when it's the right way to give the AI access to the information. How do we determine the right way? Right now it's an intuition thing, but as we develop this more, I think we'll kind of firm up what the best way to do it.
The other thing is like the reason that people are putting an intermediary between the MCP server and their application is to save context tokens and maybe filter down some things. Like for us, we are auto-generating the MCP server that only has the methods that we want it to have. So there's not we're only exposing kind of the minimum stuff anyway, so we don't really need an intermediary layer, I think.
Yeah, I think that yeah, it really does apply. It doesn't apply to us because each of our tasks has its own MCP server that's very whittled down to what it needs. I'll give an example of we have a chat bot that you can chat with in our system to so that a customer after a scan is done can ask about anything. It'll be able to deliver the data in different ways, produce new graphs for the customer that are unique to we didn't have a task that produced that graph, but they can ask for a graph and it'll generate it for them based on the knowledge we collected. And that is too large of a knowledge base for it to fit on an MCP server, right? And if we did make it an MCP server, it would have like hundreds of tools to get at the different bits of data that we've collected, and then it would take way too long. You'd wait like 5-6 minutes for the chat app to reply to you as it went back and forth with the MCP server. So in that case, we completely transfer the knowledge to the disk and give the skills-based way to access all that data. So the response time is much more reasonable, and it can still access the full set of knowledge we've collected in kind of like a JavaScript JSON database on the file system where it can use kind of terminal commands to access all the data that we have. And maybe there are better ways to do this, and as we develop and kind of investigate more, we might find better ways to do that. But right now it works pretty good. The chat can produce things that we didn't even think of when we were generating the tasks and how we'd want to report the data to the customer. The customer could be like, yeah, but what about 3 months ago? What did my bill look like then? And the chat app can actually produce a graph of whatever you're looking for over 3 months because we collected the data, we parsed it all, and we made that knowledge base available to the LLM.
Super cool. Any lessons you can share in terms of like building an MCP server?
Yeah, so lessons about MCP servers. I think that the biggest lesson is that we're glad we have to use MCP servers the way we do, right? We have a Kubernetes cluster with individual pods, isolation. The MCP server is isolated. We don't have to worry about security. That MCP server is only accessible by that one pod, and it's filtered down to the data that it needs. I think if we were going to develop an MCP server that was generalized, maybe to let anybody use their own coding agent and with our knowledge base, we're going to have our work cut out for us to come up with the best way to expose all that data through an MCP server and not overwhelm their context or we want to make it secure as well, and there's a bunch of considerations that
I saw in the I guess it was the Opus write-up. They were talking about how they had the new way to search. I can't remember the name of it, but you could search for MCP servers, and they were just showing the number of tokens that different common ones took, and the GitHub was like
The worst.
and you can see how it happens. Like if you have a rich API, if you're designing an API, you generally want to make it kind of work for all uses, right? And you sort of build endpoints for everything that you would need. But that's kind of bad in an MCP server. Like that's a lot of tokens if you expose a lot of different methods. So yeah, I don't know. When we get to building ours that would be used in our customers' coding agent stuff, I think we'll have to come up with a very kind of task-oriented, opinionated sort of particular use cases would get their own endpoints or something.
Yeah, we would have to be. We'll be clever about it when we do it. We'll have to figure out how to do it.
So how important is it to have some sort of like a robust sandbox systems to run these kinds of coding agents inside of them? And were you guys exploring like off-the-shelf solutions at all, or you just kind of knew that what you had to build was like a container, and then that's about it?
So in this case, sandbox is for like isolation. I don't know. We got to running things in containers pretty early on. Yeah. I had kind of used that approach on some other things I had built other places, and so I don't think we really considered too much else for it, to be honest.
No, and like you said earlier, when you can develop the solution really easily, like we're leveraging AI to develop our solution, so we're able to code things and throw them out if they don't work out and try different things out, and we really made a tailor-made solution to the problem we're trying to solve. Like our pods in Kubernetes, they're not just used for AI, though predominantly. That's what we want to isolate. But they can be used to just store knowledge in volumes or leveraged for other things that we want to do in isolation. So let's say we want to make 10 commits. We could try to find a way to do that without using pods, but using a pod per commit we're developing, it's much easier. You don't have to worry about anybody trampling on anybody's code, and you can work in parallel, and everything becomes a lot easier. So we didn't really consider kind of off-the-shelf products.
Yeah, but what were some? You mentioned some before. Hi, what were some?
Daytona, Vercel, Sandbox, E2B.
Mm-hmm.
Yeah.
Yeah.
Yeah, we did not.
We didn't look at them, but it's good to hear about them anyway. Like maybe somebody else will find those are better.
Yeah.
Cool. So one particular decision that I found that you made was cool, which is to rely entirely on Claude Code to do the code-based exploration once it's cloned into a sandbox. Explain to me why you guys decided to do that instead of building your own agent loop.
So we a lot of things we want to do are like find things in the customer's code, make a modification to the customer's code to fix something. To do that, you want more than an LLM. You want a set of tools. You want to run greps and finds and bash commands and so it was just too appealing to have coding agents be there, already know how to use all those tools, work in that environment, and do exactly the kinds of tasks that we wanted to ask of the AI anyway. So Cloud Code had an SDK. They were encouraging people to do that. We could see that that OpenAI's Codex CLI was open source. Gemini CLI was open source. So we had like alternatives if we ever had to move. So for me, that was kind of the calculus. It's like, okay, well, let's take a little higher level of abstraction than working directly to an LLM. And there's still flexibility there to work with other alternatives besides Cloud Code if we need to.
Yeah. We started with Claude Code, I think, and that just stuck. So we're not necessarily a Claude Code only application. We could definitely leverage all the other coding agents. But I think the thing that just makes it so we'll never develop our own is that these companies and open source foundations, they're all just making their focus is to make the best coding agent. So why would we try to develop a mediocre coding agent when we can leverage one that's just made and being improved all the time? So that really makes our lives easier, not having to worry about that part of it, right? We can just leverage all the hard work that somebody else is doing.
That's right. What's the biggest lesson that you guys learned building so far?
You brought up the MCP servers, and like we've mentioned it now a few times about how we limit the MCP servers to just the small amount of tools that are needed. I think initially we thought that wasn't the initial kind of plan, but it was a lesson learned. Like context is a big part of AI. I think that's one of the things that we needed to learn early, is to make our tasks as deterministic and kind of reliable as they can be in our system. We really need to limit the context to a really small amount, and that actually applies to when I'm working with Claude Code or any other coding agent. I really want to keep that context as low as possible. I have a status bar on my Claude Code, and it shows the context window and how full it's getting. And I watch that bar, and I'm afraid of it getting full.
Same on cursor. There's like a little shortcut you can watch.
You don't want that to fill up if you can avoid it, right? That's like scary, because as soon as that fills up, you know that it's downhill. Yeah, downhill from there. Yeah, exactly. Lobotomy time. Maybe it'll remember half of what you told it, up to that point. So, and that's one of the things that we try to avoid with our tasks by having really small, kind of repeatable things with a really minimal context window to start. We're trying to make it so that we can do everything within a single context window while we're working on the problem.
Yeah, it sounds to me the lesson here, repeated over and over, is that because you guys do a lot of things with predeterministic code and workflows, you have control over what context to put in at any given point.
Yeah.
And you actually know what context to put in, so it's more accurate, and the agent or the AI step usually get the best context possible at that step without having to make too many decisions.
Exactly, and I'll give an example. We sometimes have had tasks that are we wanted them to do too much, and so the task would like, Claude Code would start to investigate. But when you give it too much to do, you would see that the end result is not from run to run. It's more different because of the randomness in where Claude Code will go in the code or whatever. And by actually just breaking that up into smaller components, and that was one of the reasons why we developed our Lambda tasks. I don't know if I mentioned them, but any task that's running in our system, it can decide that there's 10 things to do right now, and I can ask one AI to do 10 things, or I can split it up into 10 bits of work, and if it decides to split it up, it automatically will generate 10 pods, one for each with the context that they each need to run those tasks, and they can run in parallel. And because they're running in parallel, they're faster, and also because they're focused on the individual job that those Lambda tasks give them, they're going to be more accurate in the end and giving you a better result. So that's another lesson learned, actually.
And the Lambda task thing is actually in the blog post that you guys just put out.
Yes.
About the task orchestrator.
Yeah. We like. I feel like we're all trying to figure out new ways to build software all of a sudden, and so we just wrote up some of this stuff about Task Orchestrator into a blog post, and we're happy to get the chance to talk to you about it as well. I don't know. This is how we decided to tackle the problem. And
yeah.
Do you see like a use case of Frugal outside of this particular use case? I mean, you mentioned like the coffee machine, but do you foresee a day when this is going to be like maybe open source or with that?
I doubt the coffee machine will happen, but the task orchestrator system, I could see it being leveraged for other things that a company might, a different project or a different goal that another company might have. I could see that happening.
Yeah, we've considered open sourcing it. We also have a really long list of things to do to get to launch, so we're we haven't sort of done that work yet, but I'd actually be curious to see like what kind of response we get from the blog post and what people think about this idea. Because this core system we've been talking about today is really like it's very flexible. It could be used for anything. It's just for a way to have a graph of tasks that have caching and Kubernetes plugin and some AI mixed with some deterministic. It's a good just basis for lots of systems, I'm sure.
Yeah.
Cool. Anything coming up that is exciting in the near horizon for you guys?
Well, we're in early access now, so we've got a few customers using the things now, and we're working our way towards launch in the beginning of next year. So that's we're at a really fun, fast point in the process at the moment.
Cool. I know you guys are busy, so thank you for pausing on shipping and coming out here to this podcast.
It was fun.
Yeah, I really appreciate you inviting us, and and just like we're growing, and if there's anybody out there who's really interested in this stuff, please do reach out to us, because we need help to go build all these things.
Cool. Before we wrap up, like what kind of roles are you guys looking for?
So we are looking for system engineers who can, build stuff like this. It can make this work with new services that we haven't integrated yet. Like, say we want to go reduce the cost of a pub sub system. So we need someone to go adapt everything to work with that. We need sort of forward deployed engineers who will take this out to customers and use some of the customization hooks I mentioned to make it work great in those customer environments.
Engineers who know how to both code and talk to humans.
Yeah, like
Very rare.
yeah, very rare. But that's like I think it's the one thing that like AI is not going to replace anytime soon, is that ability to take something like take a piece of software and make it actually solve a product for a person is a great place for humans to play a role in the whole process. So
cool. Thank you.
Thank
That's
you.
it for the pod.
Awesome.
thanks.